In this demonstration, I'll show you how to use the CAD input capabilities available in ANSYS TurboGrid to create more accurate meshes of complex blade geometries. This geometry is an axial fan stage with a rotor that contains 6 blades and a stator that contains 7 blades. I want to transfer this geometry to TurboGrid and mesh the stator. In the past, TurboGrid only supported geometry definition by curve files, requiring that curves be extracted using the Export Points feature in Blade Editor. In this example, I've already extracted the rotor curve and the stator curve and transferred them to TurboGrid through ANSYS Workbench. Before opening TurboGrid and meshing the stator, I want to ensure that the correct flow path and blade row are selected. Under Geometry Selection in the TurboGrid Schematic Properties viewer, I can select the appropriate flow path and the blade row that I wish to mesh. In this case, row number 2 corresponds to the stator. In TurboGrid, I can see that only the stator row is modeled. I can quickly view the imported curve to ensure that the transfer was successful. In the Geometry tab, the Profile Points option is automatically selected, and the geometry is defined by these CRV files exported by Blade Editor. To increase the accuracy of a blade geometry in TurboGrid, I can choose to import a CAD file, which is easily done by selecting the CAD option in the Geometry panel and then selecting a CAD file. In this example, the CAD file was generated in Blade Editor, so I can choose to import the CAD file instead of the curve file by simply opening Blade Editor and deleting the Export Points item for the rotor and the stator. Next, I'll reset the TurboGrid cell, refresh it, and then specify the stator blade row in the Properties viewer. Resetting the TurboGrid cell is recommended if the Blade Editor input method changes. In TurboGrid, we can see that the input mode is now set to CAD, and the CAD geometry of the rotor and stator are displayed in the viewer. In the Geometry panel, the tree is now populated by topological entities describing the different stator blade passage components. I'll select and inspect the stator blade to ensure that the transfer was successful. With my CAD geometry successfully imported, I can accurately mesh the machine's geometry. To do this, I'll disable Suspend Object Updates. The mesh was successfully created. For inspection purposes, I'll turn on the visibility for the high blade, low blade, and shroud. As you can see, I was able to use an imported CAD geometry to create a three-dimensional mesh in ANSYS TurboGrid. This concludes this demonstration showing you how to use the CAD support features available in ANSYS TurboGrid.